speaking today about synchronous programming in .NET 4.5. Anybody here have experience with asynchronous programming in general? Great. Just build a small application, just a couple of buttons and a list. Okay, the first button, can you see the code? Is it obvious? Can you see it? Okay, the first button, we just call some function, get value. Let's get value, we'll sleep, we'll wait for a couple of seconds, 3 seconds, and then return value 5. So it's basically just spreading a task, not a task, okay, spreading some action, waiting. This thread.wait can be replaced with any long process. Like you're downloading stuff from the internet, getting a file, opening it. Let's say it will take just 3 seconds to return with some value. It's a very simple example. So just hit run. And the UI stuck for 3 seconds until I get the value. Then I can move it. So I'm just calling something for 3 seconds. Everything hangs in the user interface. Okay. This is the main problem we are facing. You are getting some data or calculation or whatever, and it's taking some time. And your user interface stuck. The user can't do anything. A good developer in this situation will just change the icon to glass hour, but still you cannot do anything. Okay? Okay, we'll get to this. Just defining the problem. Why do we need asynchronous, or better is another topic, but why do we need synchronous programming? Asynchronous programming. This called synchronous mean I'll ask some function to return something and wait for it. I halt for it. Another example, I'm just going to a URL, okay, Microsoft.com. I'm getting the length, just downloading all the contents and calculating how long is it, okay, how many bytes. And we have the same issue. Of course, there's no internet. This is much worse. There's no internet, so I'm totally stuck. I cannot do anything. I have to restart the application. There is no stop button. Nothing is responsive. So. This is our problem domain. Long process do take time, okay? You are downloading something, interfacing with any input-output, getting some data from the serial port, reaching for a file or a resource on the network. This includes mostly all I/O-bound tasks, files, internet, serial, and it's working. We have the main thread. This main thread is responsible for your main loop. This main loop refreshes your user interface, get your feedback, like the clicks, the buttons, and everybody hit the hourglasses. Okay, it's nice to have an hourglass for the user or beach balls if you're using other platforms, but the users keep waiting. He cannot do another task, he cannot get any feedback, he cannot do anything. Unless you intentionally want him to really wait, you shouldn't do this. Solution for this problem is asynchronous. Asynchronous means basically non-blocking. So it doesn't block the main thread. It's meant for responsiveness. Yeah, the main target of asynchronous programming is responsiveness, feedback with the user. You don't get to block the main thread. It's not meant for performance. Performance have another topic, which is the parallel programming. Asynchronous, add overhead, and most of the time, you don't need it. If you have some really heavy task, okay? It's more client-oriented. It's meant for the application, for the user, not for the server side. Sometimes you need to use it, okay, but it's not, it's not really meant for this. This is a place where you can argue, but this is what I believe here. And it's a very old pattern. It's nothing new. Okay, people used it on DOS.
Can I give one example with my technical?
Yes?
In ASP.NET, you can make the request handle. You can make ASP.NET handle the request in a synchronous fashion. In that case, when a request comes to ASP.NET, the ASP.NET handles the request and frees the thread. As Ahmed will explain later, that's about asynchronous, which is freeing the thread. When the ASP.NET frees...
To continue on another thread.
Yeah. So in that case, you'll be able to scale your application. You'll be able to handle more loads without adding a different server. So that's one case where actually it can benefit the performance.
Yes. Here, just some general, okay, statements. If you want more details about this subject, Halabi gave a nice session about this. It's recorded on YouTube, right? Yeah. So it's a case where you have a server-side asynchronous that benefits performance. But generally speaking, asynchronous is meant for client-side applications. Usually, we wrap any lengthy task into an asynchronous call and maintain the main thread free. So I just call it and return directly. I don't block the main thread. I don't wait for it. I await for it. Okay. And the general idea of this pattern, when I call this method, I hook a callback function. I'm telling them, whenever you finish, please call this method on the main thread. This is called the callback pattern. Okay, it's used for decades now. Sometimes we call it continuation code. So whenever you finish, continue this code on the main thread. And you have to make sure to be thread safe in this scenario. I want to explain how it's done prior to .NET 4.5. It's easier in .NET 4, .NET 3, but it used to be quite complex. Now we have something called async-await, 2 keywords that I can use to simplify the asynchronous calls. And it's not new to .NET. It's not new to .NET 4.5. It has been there in F#. If you attended the boring session about F#, it was initially where the keyword async was introduced in .NET 4, but now it came to VB and C#. I don't do anything fancy, actually. Under the hood, it's the same button for asynchronous calls with the continuation code or the callback functions and everything. But I just put a directive for the compiler telling him, do the heavy lifting. Okay, this is my code. This is where I want to wait, okay, for the result. You do the rest. You figure it out. We will see in a minute. We have the keyword await. Everything after it, the compiler takes it, put it in wrap it in a method and use it as a continuation code. This simplifies asynchronous programming. And .NET 4.5 have a lot of methods, and most of I/O operations would have the keyword async after it. This is ready made for you. You just use it. We'll see this in a minute. Actually now. So this is our two methods. First one, get value. You can see it. Zoom. Better change the font. Okay. I'm a Mac user. I'm not familiar with the device.
Windows Plus.
Windows Plus. Okay. Nice. So this is our call. Just get value, returning end, sleep for 3 seconds, and return a value of 5. If I want to change this into asynchronous task, let me remove this. All I have to do is the following. I just took a copy of the same method, and I bought async task of end. Okay. Let me get the code. See, this is much cleaner code. I'm using the same function, get value, and I'm wrapping it into a task. So I'm starting a new task from the factory, start new, and passing the get value. And for the result, I just await for new task. I don't want to write code a lot here. So what I'm doing here is creating a task, okay, asking this task to execute a code, which is getting the value, and waiting for the result. I don't pass this line of code until I get the result back. So let's call it from the same button. How do I zoom out? Okay. So this is the same button call. I'll just change it to the new version, the async version. And put await in front of it. Here the compiler is saying the await operator is only used within an async method. So just have to put async here. And that's it. So if I have two versions of the same method, one is normal and one async, all I have to do, whenever I reach a point that I really need the result, I'll just await for it. And in the declaration of the method, I'll just put the word async. This is it. Let's try it out. So here, I hit run, and my UI is responsive. I can move the window around, I can interact, I can put a button for cancellation, so I can cancel this task. Set it again. So whenever it's ready, it's coming back with the result. We'll get back to the async task later to explain more. But what if I have already an async version of the, yes? Sorry?
Why couldn't I put the same method with the async and await keyword from the bottom click by the key?
This is what I'm doing. Yeah, I built another version, which is async.
Can I use the same version?
No. The same old, you want to take the same code and just put await in front of it and async and want it or no. Because async await actually awaits for a task. Okay, it doesn't await for the actual method. You have to build a task, okay, task of some enumerator, and wait for it. So if you have just an old version, you just wrap it in the task and await for it. That's it. This is the other function that gets the URL length. So just returning nothing, it's a void, and it's taking a URL string, creating a web request, and getting the response. Here an interesting point, I'm not returning an integer value or long value, which is the length of the content. I'm updating the UI directly. So here I'm accessing the list. I'm inserting an item with a value. So logically, if I'm doing this in another thread, I cannot reach for the UI directly. I have to sync the result, okay? Because the only thread that's allowed to update the user interface is the main thread. Here's the async version. Just compare them. This is the old version of the code, and this is the new version. What changed? Rather than returning a void, I'm returning a task. Okay, and I have the keyword async. And here, I put await in front of the asynchronous version of the same code. This is provided by the .NET framework. Most of the I/O operations have async version. And I'm updating the user interface directly. I'm reaching for the main thread. How would it sync? This is the compiler. So basically, when you compile this, .NET compiler will check this await and take whatever below this as a callback function. This is your continuation code and nothing else. So it will spin off the call and tell it whenever you finish, please continue this code. And the continuation is in the main thread. So how we call it? This is the old version. I'm just saying get URL length of whatever. Has to use the async version, of course. That's it. So with minimal change, it's easy, right? It didn't write any code. Just on the button click, I say it's async in the declaration, and I wait for the asynchronous version. That's all the changes you need. So actually, if I don't want to do the code this method, I'll just copy this one. And it will work fine. So I don't have to create a wrapper for it, but usually what we do, we build some helper functions, something we do use a lot. With the parameter, I'm passing like the URL. So this is just a wrapper, like you are extracting some code and put it in another method. But you can do this code directly without any issues. Just change the URL and it will work fine. Okay. This is easy enough, is it clear? Any questions? Okay. So you want to like update the user interface or do whatever, and then wait for the result. How do I use Halabi? I just call the method without the wait.
I didn't get that question, sorry.
He want to update continue doing other stuff without waiting. But you normally need to create a task and put it on the task factory and spin it off.
That depends on the UI. He has to free the UI thread, right?
My point is that the main idea of the asynchronous programming is to continue doing things while I'm waiting for the result. But if I put the keyword await, this will wait.
No. Let me show you an example here. It doesn't really. Await is where you need to get the result. The point where you need to get the result. Okay.
Can I just see that the keyword await is just a placeholder. The common language type automatically will generate the code that you usually have to write to wait for the result. So it's like you write this keyword and instead of writing all the code to wait for the result, it's written for you. So await doesn't mean wait.
Yeah. Are you familiar with yield? The keyword yield? Okay, in the I enumerator, it's the same. Whenever you reach yield, it will go out of the call directly, right? It will not be called unless you actually use the data, right? This is the same. Whenever it hits await, it will come out of the procedure, okay? And whenever the task finish, whatever you are awaiting for, it will continue back. Okay, an example of this. See here, I will hit run. What will happen? It will go call the get value and come back. Whenever get value finishes, it will put the result. I will hit run multiple times, like 3 times. So I'm doing stuff, I'm working, okay? I can have cancel button, I'm asking for something else, I can work, you can work freely. So I'm spinning 3 calls, I'm not waiting for anything. Normally, you'll get your UI blocked, you cannot hit the button again, right?
I believe, can you go back to the code, please? I believe the solution is that first line you have int result value async. I believe you want just to fire this method and then write the lines below to
No. Await will exit the function, will make like a return.
So
it's exactly like yield. Okay?
So the point is, await means you can still do your work separately. Whenever the return comes back,
it will continue from the same. Okay, we will do this right now. We'll just put some log messages and see the sequence. Okay, but you cannot, after yield, you cannot put another procedure to be called, right? You are familiar with the enumerator. So the same, but you can do other stuff. Okay, you can click other buttons, you continue typing, whatever.
I believe even here you can, but he has to use the task object itself.
Yeah, task is another, you are spinning another task or thread. This is another.
If you just use the task object itself instead of the await button, you can get a reference to the task, and the lines that you write after this one will continue running, and then you can go ahead and check if the task.
But still, whenever you are writing await, it will exit the function. Okay, it will not continue. What's doing is create the task, spinning it for you, and hooking the callback function. Whenever it's finished, it continue to the same line. Okay, but you cannot. I understand what you need now. You want to say like await and then do some extra work. No, will not happen. So let's just put some debugging messages, just to understand what's going on. So let's run this and see. Now, see here this error? Okay. Because I'm calling the UI, I'm updating the UI from within a task, which is on another thread, I got kicked out. So, I already done this in the same method body. I updated the UI here. Okay? But it will fail only here because it's in another thread. But this continuation code, the last line, will run on the main thread. Again, it stopped here, the get value, because I'm calling get value within the task. So I cannot update the user interface here also. So this is a sequence. I click the button. I entered the body of get value async and waited for get value async to be finished. And then I return it to the await finished on the button click, and then I printed the value. Does this make sense for you, this sequence? So again, come on, yes. So I entered this body of the click button. I printed button one click, so I came here, and then skip this one. It went to async value, get async value. Here, printed that I entered this body. This block of code span a new thread for the task. And I reach it here first, whenever I finish the awaiting, after the 3 seconds has finished, after this call has finished, and then I yield it back here. Continue from here. Make sense? So, first benefit, you don't care about the callbacks, you don't set up a lot of stuff. All you have to do is use the async keyword, await, make sure that any asynchronous version of your code return a task rather than a value. Okay, and that's it. So about thread safety, from within the task itself, you cannot reach for the UI without all the sync stuff, okay, because it's actually running on another thread. But the continuation code runs on your main thread. You don't have to care about it, but works just fine. Any questions? So, just for your consideration, long process take time. This is a fact of life. We have to deal with this. mostly IO-bound tasks like getting stuff from a network resource, from the internet, reading a file, doing whatever. And we have a free version of async, just you can use them. It's there in memory streams, like copy to async, move to async. All this is ready made for you. Okay. We have another problem. It's a different problem. You know, this is just pretty much all the topic for the async and await. But I get a question all the time. People are asking, what's the difference between asynchronous and parallel? So I'll just clarify the difference. We have the other problem domain is we have a single thread. It will utilize a single core of your CPU. Okay, and we reach the maximum of our gigahertz, so it's not expanding anymore. And we have multi-cores. Now, if you get a mobile phone, you have quad core, so you have 4 cores, rather than having server or a good laptop. And we tend to build more complex applications with time that deal with huge processing, big chunks of data, and we have server applications that serves more clients every day. We have server applications now that serves. If you have a website, you build a website, and you used to get like 1,000 users, you get now 10,000, 1 million. So the solution for this is the parallel. The very first common thing about asynchronous and parallel in .NET, they both utilize something called TPL, Task Parallel Library. So async use the tasks as well as parallel here. The main idea is splitting your work, splitting your tasks, okay, between threads. You'll benefit from this by not blocking also the main thread, but this is not the main concern. The main concern is to do as much work as you have in less time. So I'm talking here about the opposite, the performance. That's why when first defined asynchronous, I said it's not about the performance. Okay, it's about the responsiveness. There's exceptions, of course, but this is a general idea to differentiate between the parallel and asynchronous. So you can utilize, with parallel you can utilize your hardware more. Okay, and we have something called thread pools. This thread pool that can manage the ratios between how many threads you have and how many cores. Shall I put 1 thread per core or multiple threads? How do I schedule the timing between them? This is the operating system stuff, and on top of it, there's a layer in the .NET. Asynchronous versus parallel. As I said, generally, asynchronous is not about the performance, it's about responsiveness, and parallel is about the performance. Asynchronous for most of the time for client applications. Servers and heavy applications use parallel more. You can use it in any application, of course, but this is where it excels. So asynchronous is about doing tasks in the background. Parallel is more about doing more tasks at the same time. Okay? Asynchronous concerns about responsiveness. Parallel is concerned with hardware utilization. Asynchronous is more client-oriented, parallel is server-oriented. Does this clarify the idea, the difference between asynchronous and parallel? Because they get mixed up a lot of time. Okay, We'll do a simple demo about just to define the barrel. What's the benefit of barrel? 2 minutes. This is just a console application that start a stopwatch, okay, and sleep for 1 second and loop for 100 times. Now let's make it 10 times, okay? I'll make it 5. So, logically, this code will take 5 seconds because it's doing a task that takes 1 second, 5 times. And we have a barrel version. Of the same code that executes all the tasks on barrel. So let's run this first. Check the difference. Sorry. Not this one. So as expected, the first one took 5 seconds. Okay, second one, the barrel one took 2 seconds. Doing the same job, the same exact code, running the same exact code. So it's a huge benefit. Okay, you can span 100 if you have more cores. You can span hundreds of threads at the same time. And if you get to the code, to compare the serial versus barrel version, this is just simple for loop, nothing fancy. All I have to do here is change 4 with this version. It's called the barrel.4. Okay, we have a barrel library that have a lot of operators, but this is just a for loop, and this is the initial value, and this is the end, and the lambda expression, or the code I want to execute. Okay, so I'll just changing the 4 with barrel 4, make like 60% difference in the time. This is just a simple example to demonstrate the difference between a serial task and a barrel task. Okay? So, easy and clear. Of course, you have the B-Link library. You have, barrel programming in .NET, quite another topic, okay? But changes from .NET 4 to .NET 4.5, it's not about new keywords. It's about optimization for the speed. If you get, but you need a really big application to see the difference, especially with garbage collection. You run it, you take the same example and convert it to .NET 4, run it, do it in .NET 4.5, you will notice the difference. Okay, but this can be another topic. So change is in TBL, the task barrel library. There's a lot of optimization, but in asynchronous, there's a new async-await that make our life easier. That's pretty much it. Anybody have a question? Questions? Okay, thank you.